All right, so the first thing we're going to do, it says use a TI-84, but again, an 83 is fine. So if you don't have one of these calculators at home, that's fine. If you need to finish this up, like if we don't finish all of it and I want you to do something on your own, the 83 that you have on your tablet, it'll work too. Okay, the directions are the same. It really doesn't change that much, but I just thought since I had these calculators, we'd use them. So on the 84, or clearly I'm having to use the 83 because I don't have it set to do that. We are going to make sure it's in radian mode. So if we hit mode, it's already in radian mode if you cleared the RAM. If you didn't clear the RAM, then it may not be. But I would clear the RAM if you didn't, just because I don't know what in the world, other things were changed on this at some point, who knows. And then we're going to put this in radian mode. Okay, notice here this X key that you always use. It actually says XT theta N. So when you're in different modes, this key does different things. So when we go here and we change it to polar, now that key is going to give us theta instead of X. Okay. So we put it in radian mode and polar mode. So we're good on that, right? We're going to need to fix our window so that it works for all this and it tells us exactly what to do. So once you're highlighted on polar, then you can just hit window. We want the theta to go from 0, that looks good, to 2 pi, well that's 6.283. If you're not sure, then you could type, you could just type it in. Then the next part here is supposed to be pi over 24. Does anybody know if that's actually pi over 24? You probably don't. That's fine. So what we're going to do is we're going to go down to this, and you just do pi divided by 24, just like the paper tells you, and it'll change it to the decimal just fine. Okay, so you can type the pi's and stuff in there. Your x minimum is supposed to be -6. Y minimum, x max is 6. Scale is 1, and all this is at the top of that paper. So if you use another calculator or something, you're going to have to make sure that all that stuff is correct. Okay. Everybody good? All right. So I'm going to, so the next part, it says make sure each of your graphs graph the ball with the tail. Do you even know what that is? Probably not. That's why I wanted to kind of walk you through some of this. You do this by going all the way to the left on the y equals screen and hit enter twice. All right, so let's go to the y equals screen. Now it actually, even though we're hitting y equals, it says r equals because that's how we're graphing in polar, right? So it says go all the way to the left. So we're flashing here, but hit the left arrow key twice, and now it's flashing on this thing. Do y'all ever change that at all? Just shade and do whatever in rectangular? Okay. So you have different choices here because it's in polar mode. So at this point here, you're going to hit enter twice. And so now it has a little ball with a tail, like it said. And what that's going to do is when it graphs it, it leads with that little ball so you can see how it's graphing. And that's important in polar because sometimes it'll go around more than once, and you want to be able to see that. And if that's not there, you can't tell that that's happening. So it'll basically, you'll be able to follow what it's actually drawing for you is the purpose of that. Now, here's the thing. When you type in something, so let's just type in, I don't know, sine theta or whatever. Oh, sorry. Sine theta. And then I'm going to say, oh, I messed that up, or oh, I need to go to the next, or I need to change my graph now. If I hit clear, it clears that little ball with the tail off. All right? And I keep doing that to myself because I'm so used to hitting clear. But if instead of doing that, and it says on here, it literally says clear the graph, I would not hit the clear button if I were you unless you want to have to redo this thing every single time. Instead, if you have something over here, I don't know, sine theta or whatever, and now I need to change it, if I just go to the front of my equation and hit delete instead, I can delete the whole thing and it doesn't change that. So just pay attention to that. If you hit clear, you're going to have to go fix it again. And if you get rid of the equation in a different way besides hitting clear, it won't really be an issue for you. Does that make sense? Are we good with that? Okay. All right, so I'm gonna have you start not with the lines and the circles because we've already really talked about those a little bit yesterday. We're going to come back to that because this is still, even though we looked at them, this is a good little discovery activity to see how things change and what's happening there. But I want you to look, we're going to start with exploration 4 where it says cardioids. And so that's on the bottom of the second piece of paper here. And let's just look at, okay, well, I'm sorry. You can go ahead and turn there, but I wanted to say something else about these directions. It says, in each section there will be one graph you need to put on the paper to have an example. Some of them are more than one. Like on these, it says graph the following, and so you want to graph all of them on here. unless it tells you to graph just one. When you get to the cardioids, that's where it's telling you to graph just one. So actually graphing them all on the calculator, but it says then to graph the equation in bold in each section of your paper. So you're not going to take all 4 of these and graph them all on here. That would be way too much, okay? But you are going to graph them on your calculator so you can see them. Does that make sense to you? All right, so let's just go ahead and type this first one in. Okay. We'll do this first one together because I want to talk about some things. So we're going to do 3 plus 3 cosine theta. Okay, so that's what it told me to type in. What does cardioid make you think of? What does it sound like? A what? Cardio. And that's called cardio because it does what? Elevates your heart rate, right? If you have cardiac issues, it's a heart issue, right? So cardioid is a heart-like thing. So when you hit graph, and then watch that little ball's going to graph for you, and it looks like a heart, okay? So like I said, these are just cool. But, okay, so here's the thing. This isn't the one that you graph on the paper. But when you want to go and graph it, we're not going to be able to graph it like we did on the other ones where we just kind of know what the graph is because you haven't ever graphed anything like this before. If you go to your table, because we like going to the table, right? 2 things about the table. First of all, your ordered pairs are in R theta, which makes you think of X, Y. But in the table, it's backwards, so you want to pay attention to that, right? Second thing is we're in radians because we want to be in radians to look at the graph and all of that. But that's going to make it a whole lot harder to kind of estimate our angles on the graph, isn't it? So I'm going to give you a way to kind of cheat. When you look at the graph, you want to be in radian mode. When I look at my table, if I'm in degree mode, it's going to be way easier for me to find something close to 30, close to 60 to find it on my graph. You with me on that? So what you can do to make it easier, but there's 2 things you want to do to that, is at this point to look at the table, I'm going to go to the mode and I'm going to change it to degree mode. And then I'm going to go back to the table. Okay, but still, I don't want 1 degree, 2 degrees, 3 degrees, 4 degrees. Like, that's a little too much, right? The graph itself, the little circle graph you have on your paper, these lines are increments of how many degrees? Because this right here is how many degrees at this point? 45. So that means each one of these is 15. So I would like for my table, instead of counting by 1s, to count by 15s. How do you change that? Table set. Good. So second window table, and you only have to do this like the first time you do it. Table start 0 is fine, but the delta table is going to be 15. So now when I go back to my table, I can see at 0 I would be at 6. Don't actually graph this on the paper because this isn't the one you graph. At 15 degrees, and you don't have to graph all of these points, but I could get a 6 and maybe do it at 60 and maybe do it at 90 and just get a few points so I could get the shape. Does that make sense to you? Now, when you go back and actually graph, bam. You're like, oh, what the heck happened? What the heck happened? It's in degree mode. So that's one bad thing is you have to like switch back and forth. But, you know, I was thinking, because I did this on the 83s and I was like, dang it, it doesn't work on the 83. And then I thought, oh no, I forgot to change my mode. So I'm going to change it back to radian so I can see the graph. Now, you're not going to have to change back and forth 1,000 times. You put it in radian mode, you graph all these that it asks you to graph so you can see them, and then you would only really do that on the one bold one. Now, if you want to graph it and look at the radian and the table in radian and figure that stuff out, knock yourself out, but that's going to be a lot more brain consumption that you don't need to worry about, okay? Does that make sense to you? So it's going to have you graph these, and then now, so it says, observe the graph, then clear the graph. What it's telling you is don't try and graph all of these on that same one, or you're not going to be able to see anything. But when it says clear the graph, I wouldn't clear it. I would go over here. So the only difference between these two is what? Plus and minus. I would just go change that, and you don't have to retype everything, right? So just kind of go back and edit. But I'm telling you, if you hit clear, it's going to clear this thing out right here. You with me on that? So you're going to go through and kind of discover things, and then there are a few questions, so make sure you pay attention to that. Describe how the cardioid changes. It's above, below, left, right to the pole, diameter of the pole width. You know, what changes when you change the number, what changes? When you change the minus to plus, when it's sine or cosine, like just kind of describe how it changes when those things change. Does that make sense to you? We're good with that? Any questions? And this really does a really great job of just following you through and then kind of explaining things to you. I want to talk about the pronunciation of some of the other stuff real quick. So when you go to this, exploration 5, have you seen this word before? Okay. This word is limaçon. That's how you say it, limaçon. And the C actually has like this weird tail thing on it. I can't do it small. It's going to look weird, but there's like a weird tail thing on it. You might have seen things like that, and I don't even know what language it is, probably French or something. But that's limaçon. It's okay if you don't really remember how to pronounce it. I just want you to at least know. And then there's 2 different kinds of those, and then there's a rose, and then the last one. Anybody seen this word before? That's limniscate, like limp biscuit. Limniscate, that's how I remember it. Limniscate, it's like limp biscuit. It just kind of sounds like that to me. But that's what that is. Whether you can, but it leads you through it well. It gives you, this is the equation. Then it says, what would you need to put in your calculator to make a graph? You're correct. Okay, so then it just helps you. So if you don't know, it's there. But it tells you what to type in, and then it gives you the generic forms, and just for you to have a basic overall understanding. Okay, you don't have to memorize all this and be able to repeat all this to me on a test. But we are eventually going to graph some of these by hand, but by hand with the calculator. Okay, the calculator giving us a table, basically the same way you're going to be graphing it on here, getting some points just to get the shape and the idea. Okay, are we good? So I want you to start back at the cardiology with exploration 4. Start there. That doesn't mean you're not going to do the lines and the circles, because I do think that that's powerful as well. But I'd really rather spend more time, and we'll kind of see how much time this takes you, because I think this will be good for you. All right? Any questions? Good? Awesome.